Hi everyone, thanks for joining. Today, my colleague Ricardo and myself, Luke, will be speaking through our efforts to migrate bioinformatics workflows across different engines at Genomics England, doing this while running a live clinical genetic diagnostic service. We'll be speaking through the chosen migration strategy, explaining our risk mitigation approaches, and sharing lessons learned. We hope that you learn from our experience. Starting with the migration strategy, Genomics England uses a workflow engine that was internally developed for most of its clinical bioinformatics workflow processing, named Bertha. This has served us well, but it is time to move to a wider use system. We've decided to move to a Nextflow-based system named Genie, which will help us support cloud infrastructures, newer use cases, and also scale better. Our top priority when working through this migration was minimizing risk for our patients, particularly because the results of our workflows have a direct patient impact. We needed to minimize divergence between the legacy workflow engine's results and the newer system, known as Genie. We knew that working in an agile fashion, regularly delivering value in small iterations, would help us achieve this goal. Our priority was also to migrate as fast as we can, to retire the legacy workflow engine and simplify our tech landscape. Luckily, most of the bioinformatics code that Bertha calls is stored in a Singularity image already. To migrate, we've simply written helper code so Genie can run the Bertha bioinformatics code in its current form. The advantage is that setting up Genie to run Bertha workflows has actually been quite quick, and the risk of behavioral divergence between the two systems has been reduced significantly. By using this approach, we can use the same Bertha bioinformatics algorithms from Nextflow, allowing us to migrate quicker and deprecate Bertha faster. Once obsolete services are deprecated, the plan is to optimize and refactor the bioinformatics code in the Singularity image to make it Nextflow native. We will also be employing an agile approach of small iterations and regular value delivery during this process. And now we'll move on to our risk management practices that my colleague Ricardo will speak through.
As Luke said, we need to minimize the risk of divergence during the migration. One of the first initiatives that we used to improve testing was to set up a containerized environment where we could run the workflows. We used Docker Compose to simulate the production environment. We used this testing environment to run workflows locally and in continuous integration before merging code into the main branch. Our system, Jasmine, allows to run the same pipeline using both the legacy and the new workflow manager. With these runs, we can automatically validate that the results and side effects are consistent across workflow managers. Given the complexity of the workflows that we are migrating, we run the test in sub-workflows. This way, the test keeps a low complexity, the work can be parallelized, and errors are easier to track. Finally, we want to share some of the lessons that we have learned across this process. Lesson 1. Using a containerized environment allows us to use the same shared code across different workflows, enabling the continuous development of components in the legacy workflow without blocking the migration effort to Nextflow. Lesson 2. Making small changes means that we can keep iterating forward while keeping the system running, and it's easier to find errors caused by regressions. Lesson 3. Black box testing allows us to ensure that the pipeline is working without the need to understand every single detail in the complex code base. Lesson 4. Automated integration has allowed us to make sure that changes up and downstream the workflow don't have unexpected side effects early in development.
Lesson 5. We joined up the Jasmine comparison tests for different Nextflow modules into groups of 2 to 3 modules each, which reduced the amount of test input data that we needed to generate, making test implementation quicker. Lesson 6. We generated tiny test data for our Jasmine test cases, which allows the test scenarios to run in CI quickly, giving us fast feedback and confidence in our migration. Lesson 7. Starting our Jasmine comparison test scenarios with services having a blank state greatly improved the robustness and reliability of the tests, We recommend always using a blank slate when starting tests where possible. To sum up, we have spoken through the migration approach of our bioinformatics workflow engine from our in-house workflow engine Bertha to a Nextflow-based one, Genie. We have spoken through how we're staggering value delivery to mitigate risk. We described our automated testing framework, Jasmine, and how this is giving us confidence in our migration work. Finally, we shared our top 7 lessons learned while working on this project. Thank you for watching our video presentation, and we look forward to answering any questions you might have, whether via email or in person in Lyon. Goodbye.